Welcome to another practical physics walkthrough supporting your labs at Godalming College. We are going to be looking today at the refractive index of glass and also the critical angle of Perspex, effectively looking to study how light enters and exits objects. You'll cover this in class through Snell's law, but today, week 3 introductory experiment, really about developing some of those measurement skills. A little bit of practical calculations involved. We'll start to think about how to minimise our uncertainties. So the kit you're going to use today: glass block, semicircular Perspex block. We've got a light box, which is just a light bulb in a box. We've got a orange lab pack and a protractor as well. Whoops, camera works a bit rubbish. And effectively what you're going to do is measure angles of incidence, so light beams coming into a glass block. Because we can't directly measure these angles of refraction within the glass block, we're going to find the points where it exits the glass block and then we'll be able to join the dots. This is the method that I'm now going to take you through. Okay, so I've just drawn around the glass block, so I've got a rectangle on my piece of paper and I've just marked any old random point. I don't want to have to keep marking my angles of incidence as I'm performing the experiment. So what I'm going to do is stick a protractor very carefully, making sure it's lined up. I'm going to mark normal 10, 20, 30, 40, 50. Make sure I don't move that protractor. 60, 70, 80. I don't need to put 90. And you can now see that I've got this set of marks. You'll probably do it a little bit more carefully than me. I can now join them up, and these will give me my normal line, ten, 20, you do them all. I'm just going to do one over here just so we can use it later on. Normal, 10, 20, 30, 40, 50, that's 60. Okay. And that is going to allow me to really quickly take my initial measurements. Let's replace this glass block, and in actual fact, having all this paper here is going to be a real faff. It's going to get in the way, so I'm going to cut it off now. So you can see that I've positioned my light box and I've got my lines drawn on here, and what I'm going to do is I'm going to line up the left hand edge of this line. You could use the right hand edge, doesn't really make a difference. I want to make sure that that left hand edge is right at the point where I've marked on where the light beam should enter the block, and it exactly follows the pencil line that I've drawn. Now at this stage you can see, because of the light bevel and all sorts of things, I can't see exactly where it enters exits the light block. So what I'm going to do is I'm going to mark a couple of points on that line. I'm going to mark it as normal so that I know what it is. And that way I'll be able to extrapolate back and I'll be able to see exactly where it exits the glass block. Now I want to move it round to my 10 degrees point, being really careful that pencil line follows the light beam all the way through. I can now make a couple of points. There we go. So I've made a couple of little lines there so that I'll be able to extrapolate it back to the glass block. make sure that I mark that as 10 so I can see what's going on. Do the same thing for 20, I'm not going to do it for all of them. You will, right, so now we've got, oops, 20, it's not a very good line. Okay. Let's go all the way to 60, and that's bang on. Really careful not to move my glass block. There, and there. So now I need to find out where each of these lines exited the glass block. So all I do is just extrapolate back, draw these lines in, that's shocking, it's there. And you would obviously do it for each of them, but what we've got now is really clean points where those beams exited the glass block. We don't care about the angles of these lines, if I'm honest. What we care about is I can join up this point with each of these points, because it's this internal angle, this angle of refraction that I'm going to be interested in. And again, do it carefully. You would obviously have 8 points. And it's this angle I'm interested in. It's always from the normal to my particular line. So it'd be that angle, then it'd be that angle, then it'd be that angle. And actually what you're going to record in your table is, make sure I've got it to normal, lovely. I can see that's normal. So here I've got an angle of refraction of, oh, what is that? 10, 11, 12, ooh, I want to say 12 degrees. Now I've taken all the measurements, we're going to make sure we've recorded all the results. So there's our angles of incidence we've already filled in. We've written in our angles of refraction. Then what we need to do is calculate sin I and sin R for all of the rows, because ultimately that's what we're going to plot. As long as it's from air into a material, we can use this version of Snell's law, sin I equals n sin R. We're after this n, the refractive index. Chuck it into y equals mx plus c. We can see that we plot sin I on the y-axis, x is sin R, and the gradient hopefully will be n. I've already done this using the wonders of Excel. Let's make that a smidge smaller. So from this I've got a reasonable set of results by the look of it, and my gradients come out to be at 1.23 as I've calculated it. Clearly when you do it, you're going to draw a lovely big gradient triangle and calculate dy and dx and work out the gradient from that. And that's the end of this particular bit of the experiment. If we look back at the sheet, you've got a series of questions to answer. You've also got to look up a standard value for refractive index. You'll find that in Yarwood and Castle in the pigeonholes in the lab. You could of course look it up online. Whichever way, you must write down in your lab book where you got your refractive index of glass from. Answer the questions, and then you've now finished the first part of the experiment, and you can move on to the second one, which is much shorter, which is finding the the critical angle of Perspex. For that experiment, we're going to use semicircular block, because this means that we can now have all of the angles coming into here as being normal. That means that we don't need to worry about measuring that angle. We know it's 90 degrees, so it's fine. You're going to have a little read of the theory beforehand, and you can see we've got this instant ray at the normal. It's definitely going to hit the centre, and if you look closely, we've marked where the centre point is here. I strongly recommend you check that. Do not trust that centre point, because it's somebody else who's drawn it on. Get a ruler, measure, and find the centre point. I'll let you read the bump, but I am going to quickly perform this experiment now. So just as before, I'm going to draw around this glass block, and on the paper I'm going to really clearly mark this centre point so that I can line up my light beam very clearly. I don't need to do any angles because we're not going to do lots and lots of different angles. So I've got the Perspex lined up with the glass block, and the light ray is going directly through that centre point. This is just going to be a single measurement, so I'm just going to move this round, and as long as that light ray keeps going through the centre point, I know it's going to be going normally into the Perspex block. And I keep rotating it round, keep rotating it round, we're starting to see a bit of internal reflection. It's not total internal reflection because I've still got a refracted ray. But I'm going to keep rotating it round, making sure it's definitely going into that centre point. At this stage, you may find it useful to get a little piece of paper to act as a little screen so you can see if there's still any refracted ray. You actually get asked a few questions about what happens when you get... I've just moved it. You actually get asked a few questions about what happens when you are really close to this critical angle. I can still see a little bit of refracted ray, still see a smidge, gone. At this stage, be really careful not to nudge anything, and make sure you mark a couple of points on that light ray. Make sure you pick a left-hand edge or a right-hand edge consistently, and exactly the same on here, a couple of points so that we can extrapolate it back to the centre. I can now nip this off, and hopefully when I line this up and my 2 points, they should all line up nicely. I can draw a nice clean line in, spin it round, do exactly the same here, and thankfully they do all line up. I can now use a protractor to measure this angle. This is not the critical angle. Okay, this is double the critical angle, and the reason why I'm doing that is because then I don't have to try and work out a normal. And what you're going to do is you're going to use that to calculate the critical angle, and from there you'll be able to find what the refractive index of Perspex is. To do that, you're just going to follow these instructions. There are several questions to make you think about what was good about the way you took your measurements, what was slightly dodgy. You've got another data book value to look up and then make a comparison and to work out a percentage difference with a little bit of a conclusion at the end. I'm not going to do that calculation for you because you've got to think about a few things. Hopefully you have found this little walkthrough useful for how to find the critical angle of Perspex, and then previously how to determine the refractive index of glass. Now you've seen how I've done it, hopefully you'll be more productive in class and be able to get that experiment done quickly.